The UK's new DragonFire laser system may have just made drones completely useless. Forget missiles, fishnets, or jamming systems. This weapon melts targets out of the sky silently, instantly, and for just $13 a shot. In a war where drones dominate the front lines every single night, DragonFire flips the script. It doesn't run out of ammo, it doesn't miss, and after its latest test, the UK's Ministry of Defence is putting it into production. Now, the DragonFire isn't just another prototype. It's a domestically built weapon that could redefine how drones are countered on the modern battlefield. So, let's break down what this system really is, what makes it so devastating, and why it could be a nightmare for drone warfare moving forward. The domestically produced weapon could revolutionise anti-drone warfare in the UK and beyond. So let's dig into the story, what makes laser weapon systems so effective against drones, and how the DragonFire fits into the global laser weapon system architecture. Following the latest successful tests of the DragonFire system on November 20, the UK's Ministry of Defence announced the signing of a contract worth $420 million with the manufacturer, defence firm MBDA UK. The contract will enable the firm to continue developing the system and install it on a number of British Type 45 destroyers within 2 years. Announcing the deal, Luke Pollard, the UK's Minister for Defence Readiness and Industry, said, "This high-power laser will see our Royal Navy at the leading edge of innovation in NATO, delivering a cutting-edge capability to help defend the UK and our allies in this new era of threat." During the test, DragonFire targeted drones flying at 400 miles per hour, twice the speed of a Formula 1 racing car, along Scotland's Hebrides range, and brought them down with precision. It's the latest successful test of a system that looks set to be delivered a full 5 years ahead of schedule and within budget. Almost unheard of in an age where budgetary and development overruns are all too common. DragonFire is led by the Defence Science and Technology Laboratory, DSTL for short, on behalf of the UK MOD, working with its industry partners MBDA, Leonardo, and Kinetic. The system stems from an initial 2017 grant from the Chief Scientific Advisor's Research Programme of the British MOD, of approximately $39.7 million to showcase the capabilities of LDEWs. Later, a roughly $132 million collaborative investment with industry players was made to further the technology. First trials against static targets at the DSTL Porton Down range were made public in late 2022, after DragonFire completed its first high-power firing there in October. Low-power tracking trials had already taken place earlier that year, in July 2022, at the Hebrides range. In January 2024, the program achieved another major milestone with its first successful high-power shot at an airborne target. Since then, additional trials through 2024 have continued to validate the system's performance. And now, following these successful demonstrations, DragonFire has been officially approved for installation aboard British destroyers. That makes it the first European-built laser-directed energy weapon system, or LDEW, to be actively deployed. It's certainly not the first LDEW to be deployed globally, or the only European LDEW in development, as we'll see a bit later. Still, it's an impressive achievement by the UK, especially considering that the system is entirely domestically built from local components. Technically speaking, DragonFire is a solid-state laser weapon that uses doped glass fiber bundles and a beam combining mechanism designed in Britain. It searches, detects, and evaluates possible threats using 3 apertures on its beam director. DragonFire is initially cued onto the target by an external sensor, typically a radar, which provides the course tracking data, pointing the system in the direction of the target before it takes over precise visual tracking. Then, similar to a pair of binoculars, the first apertures scan a large area for threats, particularly drones. After identifying a possible threat, the device then examines the target through a second middle-range aperture to provide further detail. The beam director appears to be a telescope, and the ultimate aperture functions similarly. Once the threat has been accurately identified and locked onto, the laser fires. The laser source is created by compressing raw electrical power, focusing and stabilizing the powerful beam using hardware and algorithms, and targeting the beam to ensure that all of the energy lands on the target. A series of fast-moving mirrors, or FMM, is used to steer the beam. High-speed cameras coupled with advanced algorithms provide continuous feedback, rapidly adjusting the mirrors to ensure the beam stays exactly focused on the target. Control must be exceptionally accurate, as even tiny adjustments in the position of the mirrors result in large movements of the beam up to several miles away from the mounting. To prevent the mirrors from being destroyed by the powerful laser energy, defense company Leonardo, one of the contributors to the project, has selected special materials and developed low-absorption coating technologies. MBDA leads the project, supplying the command and control system and using expertise derived from their missile portfolio, advanced image processing and tracking algorithms. Kinetic provides the fiber amplifiers that deliver the laser source, and Leonardo built the beam director. Kinetic also provided the test range, putting the system through numerous simulations of turbulent seas and unpredictable enemy trajectories. Besides the obvious shot in the arm to the UK's naval capabilities, particularly in combating high-speed drones, the DragonFire contract is also a welcome boost for the UK defence industry, particularly in Scotland, where the system will primarily be built. According to Scottish Secretary Douglas Alexander, DragonFire represents a defence dividend for Scotland, with the programme set to deliver new skilled jobs and economic growth for the region. The Royal Navy anticipates 590 jobs being created or sustained altogether. Chris Allam, MBDA's UK Managing Director, called the deal a big milestone, adding that it's proof that government and industry working together can get game-changing capability to sailors who need it now. The system will undoubtedly provide a new dimension to the UK's daring class of Type 45 destroyers, which currently rely on Sea Viper missiles, the onboard 30mm cannon, small arms, and the Phalanx system to deal with aerial threats. As demonstrated during the UK's engagement against the Yemeni Houthis in the Red Sea in December 2023 and earlier in 2025, Sea Viper missiles are more than capable of taking down Iranian-made or inspired drones. However, at a cost of over $1.3 million each, it's not feasible to use them to take down drones that cost mere thousands of dollars, except in emergencies. The cannon and Phalanx systems are also effective, but come with far greater risk, since they're most effective engaging targets at close range. The DragonFire solves both these issues elegantly. While the DragonFire's range is classified, the MOD claims that it can engage with any visible target with the precision of hitting a £1 coin, which is less than an inch in diameter from 0.6 miles away, and without any engine roar or smoke trails. As observed in the latest tests, the laser corrects for the drone's speed, altering in real time to hit them in mid-air. In less than 10 seconds, the laser beam melts the drone's airframe, long before it reaches suicide drone strike distance. Now, let's look at the cost of unleashing the Dragon. One of the main benefits of the use of drone swarms by the likes of Russia and the Houthis is the high cost involved in shooting them down traditionally. Air defense stockpiles are quickly eroded, in Russia's case, leaving gaps for more expensive high-payload missiles to follow through the drone-depleted defenses. And to make matters worse, both Russia and Ukraine make significant use of decoy drones to overwhelm and deplete air defenses. Compared to firing missiles like the Sea Viper at drones, the DragonFire turns the cost equation on its head. The MOD claims that each firing of the weapon only costs around $13 per shot. Thus, going from spending hundreds of thousands or even more than $1 million to shoot down a weapon that costs perhaps tens of thousands completely reverses the situation. Another major benefit that the DragonFire delivers is theoretically unlimited ammunition. The weapon requires no magazines or reloading, so provided there's sufficient power and cooling, it can keep on firing cheaply, accurately, highly destructively, and indefinitely. Plus, one area where the DragonFire may be significantly ahead of some of its rivals is in over-the-horizon tracking. One well-known limitation of LDEWs in general is that lasers move in straight lines, and so the Earth's curvature limits their visibility from the deck. DragonFire, which is linked to radars on ships, planes, and even distant networks, can stare over the horizon, spotting and striking enemy targets hiding just beyond sight. The latest trials reveal that it accomplished this task with ease, underscoring how far directed energy weapons have progressed since early prototypes failed in the lab. During 2021, a Thales-led consortium including BAE Systems, Chess Dynamics Vision Force EE, and IPG began working on a project dubbed Project Tracy to produce advanced demonstrators for the Royal Navy. The first objective was to conduct an LDEW trial on a Type 23 frigate in 2023. But this was abandoned, most likely due to lack of maturity, and so that funds could be redirected into other programs like DragonFire. Of course, as mentioned earlier, while the UK may be the first European nation to deploy a naval LDEW, it's far from alone in developing them, which highlights just how seriously militaries around the world are taking them as key weapons of the future. LDEWs offer several key advantages over traditional kinetic-type weapons like electronic jamming, guns, missiles, and interceptor drones. As already noted, the cost per shot is really low, especially compared to missiles, and there are far fewer constraints on how often they can be used. There are no magazines to be reloaded. Provided there's power and cooling, you can theoretically keep firing for as long as there are still targets in the sky. Unlike more traditional weaponry, LDEWs also engage targets at the speed of light. That means they hit their targets almost instantly, which provides a significant advantage when targeting fast-moving swarms of drones. Their high engagement rate, often up to 20 shots per minute, also makes LDEWs particularly effective against drone swarms. They're also capable of extremely precise targeting, enabling an operator to target specific drone components like rotors or sensors. This ability to avoid hitting the explosive parts of a drone can help to minimize collateral damage from downed drones, especially in built-up areas. It's unclear at this stage whether DragonFire has this capability, but some other LDEW systems also feature graduated effects. Operators can adjust the laser dwell time to either disable drones by, for example, melting the motor or battery, or to turn them into a fireball by targeting their warheads. In other words, the weapons can be tailored for either lethal or non-lethal purposes. In terms of competitors to the DragonFire, the US is considered to be the leader by some distance in LDEW development, as it is in most other weapons classes. Having already fielded the experimental 30kW LDEWs system in 2014, more recently deployed the AN-SEQ-4 Optical Dazzler Interdictor Navy, or ODIN, counter-drone system on some of its destroyers. The 150kW class Laser Weapon System Demonstrator, or LWSD, was tested in 2020. And the 60kW high-energy laser with integrated optical dazzler and surveillance, or Helios system, was fitted to the USS Preble in 2022. The US is also working on the 300kW high-energy laser counter ASCM program, or Hellcat, to defeat anti-ship missiles. While UK efforts are inevitably on a smaller scale, with DragonFire understood to be in the 50 to 100kW range, the program is still designed as a sovereign British capability. However, some supporting technologies, such as the naval power and energy storage systems used to handle the weapon's electrical demands, have been developed through UK-US collaborative projects. The only other NATO member currently fielding an indigenously developed LDEW is Turkey. That said, its Nazar system, introduced in 2021, is not an exact analogue of DragonFire. Nazar focuses on disrupting optical and electro-optical sensors rather than burning through targets, allowing it to interfere with guided missiles and reconnaissance systems without requiring destructive power. Mounted on naval platforms, Nazar enhances Turkey's maritime defense by offering protection against surveillance and targeting systems. However, Turkish officials have emphasized that Nazar operates in the electronic warfare domain, jamming and confusing incoming threats using high-precision light energy rather than shooting them down. Turkey does have a more direct competitor to DragonFire, however, the Alka. This is a dual-mode system combining electromagnetic jamming and high-energy laser technologies, developed by Roketsan and unveiled in 2019. It's designed primarily for counter-drone operations, especially against UAV swarms. In laser mode, it can reportedly destroy targets at around 1,640 feet, while its electromagnetic mode reaches roughly twice that distance. And the system can even disable entire drone swarms at ranges of up to 4,000 meters. However, it's primarily a ground-based weapon, usually deployed on self-powered 4x4 vehicles, though its fixed variant is designed to be integrated onto ships and coastal sites for naval protection. ACLA reportedly tracks targets with 0.3-inch accuracy at 3,300 feet and can engage at speeds of up to 93 miles per hour. It was allegedly used in Libya to destroy a Wing Lung 2 UAV, potentially marking the first wartime use of a vehicle-mounted combat laser. Australia also has an LDEW in active service, the EOS Apollo Hell. Similar to DragonFire in power at 100 kilowatts, this system is scalable to 150 kilowatts and is containerized for transportability due to its primary focus on land-based targets. The EOS Titanus system combines the Apollo Hell with radar and command and control capabilities, including anti-drone functions. Another LDEW closely associated with a strong military partner of the UK is Israel's Iron Beam, a system that's not yet fully in active service, but whose first operational deployment is expected imminently. Developed through a joint effort between Rafael Advanced Defense Systems and Elbit Systems, Iron Beam delivers 100 kilowatts of high-energy output and is specifically designed to intercept rockets, mortars, and drones. Its purpose is to serve as a cost-effective, high-volume supplement to its existing layered Iron Drone, Arrow, and David Sling air defense systems. Iron Beam has been engineered to work in direct coordination with the Iron Dome system in particular, which, while highly effective, relies on Tamir intercept missiles that cost around $40,000 each. Iron Beam dramatically cuts that cost down to around $3 a shot, offering a near zero per shot expense. Another former British colony or mandate that's fielding a prototype LDEW is India. Like the UK, India has been actively pursuing directed energy weapons since at least 2017. Spearheaded by CHESS, the Indian Centre for High Energy Systems and Sciences, and LASTEC, the Laser Science and Technology Centre, the Durga 2 is a 100 kilowatt class laser capable of engaging threats across land, air and sea. An initial 1 kilowatt prototype that successfully targeted metal plates at close range has subsequently been expanded to address power scaling, beam accuracy and durability. The system is ultimately envisaged to be multi-domain, capable of being installed on army vehicles, naval ships and airborne platforms. India has also reportedly successfully tested a more powerful 30 kilowatt Surya laser, which can target high-speed missiles and drones up to 12.4 miles away. In the Pacific arena, Japan and South Korea have both made significant advances in recent years to close the gap with the region's LDEW leader, China. Both nations are scaling their efforts through military investment and accelerated technological development, aimed to deploy practical systems for real-world defense needs. For example, Japan revealed a 10 kilowatt laser weapon mounted on an electronic warfare vehicle during a 2024 defense showcase. Although 4 times less powerful than DragonFire, it serves a targeted purpose of bringing down small drones, surveillance equipment, and sensors in tactical situations. The system currently exists as a truck-mounted weapon, although Japan has plans to scale it up for use on naval and air-based platforms. South Korea, for its part, has already unveiled its Block 1 anti-aircraft laser system with a cost per shot of as little as $1.50, intended primarily for short-range defense in populated or contested zones. It is quiet, stealth-compatible, and has a low thermal signature, ideal for intercepting small drones and loitering munitions like the Jeren. China's use of LDEWs dates back to at least 2006, when there were claims that China used lasers to blind a US satellite. However, more recently, China has widely deployed its Silent Hunter system, a 30 to 100 kilowatt laser system, originally vehicle mounted, but now also deployed on Type 071 amphibious ships for drone defense and light vehicle neutralization. However, besides Silent Hunter, also known as the Low Altitude Laser Defense System, or LAS, China's military-industrial sector continues to invest heavily in directed energy, aiming to develop systems that can interfere with satellite sensors and even disable guidance on enemy missiles during flight. Russia, needless to say, is also in on the act. Its Peresovet system is an anti-satellite laser system introduced in 2018 that reportedly has a 124 to 683 mile engagement range, focused on sensor disruption of satellites in low-flying orbits. Given the US's overwhelming dominance in satellite surveillance, if this supposed superweapon does what Russian President Vladimir Putin says it does, Peresovet could level the playing field considerably in the event of a large-scale war between Russia and NATO. During the war in Ukraine, Russia also expanded into ground-based tactical applications with the deployment of the Zadira LDEW, which has reportedly been successful in neutralizing small unmanned aerial vehicles. Russian officials promoted the system as a fast-acting, low-cost alternative to missile-based defense in environments saturated with drones. That said, with the strong tendency of Ukraine to destroy Russian equipment, and said equipment often not working as intended at the best of times, perhaps it's no surprise to see reports of Chinese silent hunters deployed by Russia in Ukraine. In October 2024, Chinese LDEWs appeared to be protecting Iran's supreme leader, the Ayatollah Khamenei, during a rare public sermon. For its part, Ukraine has developed and deployed the domestically built Trizub or Trident LDEW, primarily to counter Russia's nightly German swarms. Like DragonFire, it destroys drones by heating critical components, traveling at the speed of light for near instantaneous engagement at a cost of a few dollars per shot. Although the UK might be the first European nation to deploy an LDEW, others are hot on its heels. Foremost among those is Talos, or Tactical Advanced Laser Optical System, a pan-European project led by France's Silas with 16 partners, including the aforementioned British Kinetic, MBDA, and Italian giant Leonardo. The project aims to enable European laser weapons exceeding 100 kilowatts. MBDA is also working on a separate LDEW with Rheinmetall of Germany, the Rheinmetall Naval Demonstrator. The company's recently delivered a working naval laser weapon demonstrator to Germany. MBDA is also working with Leonardo on a lightweight naval laser system, and France, separately, is developing the Helmer P anti-drone LDEW and a French Navy laser system. So, with all this rapid development of LDEWs to counter them, does that mean that the drones' days are numbered? Are LDEWs like DragonFire about to ensure that drones disappear into irrelevance as quickly as they emerged? Not exactly. For all the many benefits they deliver, there are still significant drawbacks to these weapons. They don't work as effectively in all weather conditions. Performance degrades in fog, rain, dust or smoke due to beam scattering and absorption. Most LDEWs also require line-of-sight targeting, meaning they cannot engage targets hidden behind obstacles or flying below the horizon. However, as we've seen, DragonFire has already pushed beyond traditional limits by demonstrating above-the-horizon engagement, allowing it to track and engage targets that sit above the Earth's curvature, even if it still cannot hit those physically obscured from view. More powerful LDEW can also be affected by the thermal blooming effect as the air around the beam is heated up, defocusing the beam. This is a particular issue when countering a missile threat head-on, as the beam's position will be fairly static. Also, while they may be able to melt a P at 650 yards on paper, in practice, it's not that simple to track and engage a fast-moving, possibly maneuvering target over time. Effective engagement requires precise tracking and several seconds of beam on target, which may not be possible, especially in disadvantageous weather. Laser beams have also limited effectiveness on certain materials, with reflective or thermally resistant surfaces potentially reducing the laser beam's impact. So, As LDEWs proliferate, expect to see enemy drone makers increasingly using laser-resistant materials as a countermeasure. Obscurants such as smoke can also be used to dissipate the beam, although this is a solution of limited utility, particularly in the naval theatre. Finally, while their extremely low cost per shot makes them cost-effective in the long term, laser systems have high upfront development and integration costs. Put it all together, and LDEWs offer a balanced middle ground compared to radio frequency jammers or kinetic interceptors. They're more precise than jammers and more sustainable than guns, but require clear conditions and stable power for maximum effect. Thus, while not replacing them, DragonFire is an excellent addition to the UK's existing drone defences and is sure to stimulate even further innovation in the future. We'll keep you updated on all the latest developments in the exciting, if a little scary world of laser weapons. So make sure you subscribe to the channel so you don't miss out. Thanks for watching.